okay, solving quadratics with this quadratic formula. Quadratic formula will always work, and there are actually programs out there that have, some calculators have the quadratic formula built into it, and there are programs out there that you have that have it built into it. The quadratic formula hopefully is something you're familiar with. It's something you should have seen, dealt with, played around with, and used many times before. So the quadratic formula will solve quadratic equations without having to worry about factoring or using any other method. But you always have to set your equations equal to 0. It only works because it's finding the 0 of a quadratic. Right? It's using the property where it's finding the 0. So your first step is always set it equal to 0 first. Same thing's true when we factor. We always set it equal to 0 first. Alright, so step 1. And then we're finding the zeros. Alright, the zeros are found using this equation. And it has to do with the relationship between the square term, the x term, and the constant term. And again, we don't go into that in this class. Right, but that's where it's coming from. It's coming from, it actually has to do with distances a little bit. Alright, but you just have to know this formula. My zeros for quadratics are always found by taking the opposite of the b, plus and minus, because there are two possibilities. When I have the square, when I undo the square, it has to do with undoing the square. B squared minus 4ac, and that's all underneath the square root. And then it's that whole thing divided by twice the a term. Alright, so I'm going to solve the following using this quadratic formula. Alright, so the biggest thing is just make sure you plug the a, b, and c in, and be careful when you do. Set it equal to 0 first. So this one I have to set it equal to 0, which means I need to move the 46 to the other side, 46x. And so I add 46x to the other side, so it means I've got 8x squared plus 46x plus 63 equals 0. I find the zeros using my quadratic formula. So there's my a term, there's my b term, there's my c term, and then I just plug them into that equation very carefully. Alright, so the first thing, it's opposite my b term, so it'd be negative 46 plus minus the square root of my b term squared, so 46 squared minus 4 times a, which is 8, times c, which is 63, all over 2 times my a, which is 2 times 8. And then you just make sure, you can plug it all in your calculator in one go, although what I usually do is I simplify under the root first and under the denominator, so all order operations. So I'm going to simplify under here, multiply that out on my calculator, and so I get negative 46 plus minus the square root, that simplifies to 100, all over 16. And then there are two answers. Again, I'm going to go ahead and find the square root of 100 because it's a nice number, so it would be negative 46 plus minus 10 over 16, and so there are two answers because of the plus minus. There's x equals negative 46 plus 10 over 16, and x equals negative 46 minus 10 over 16, and then you simplify those. And so the two answers I get, negative 46 plus 10 would give me a negative 30 over 16, which reduces down to 3.25. So one of the answers is negative 2.25. And then this one would be negative 56 over 16, and so that reduces down to negative 3.5. And there are the two zeros of that equation. My two answers, negative 2.25 and negative 3.5. Alright, next example. So again, first thing I have to do is get it in the form ax squared bx plus c, so I have to simplify this. First thing I do is multiply through by my x. So I get 5x squared plus 19x equals 4. Move the 4 to the other side. So 5x squared plus 19x minus 4 equals 0. So a is 5, b is 19, c is negative 4. Plug it into the quadratic equation. So you plug it into the quadratic equation. The opposite of b would be negative 19 plus or minus b squared, so 19 squared minus 4 times a, which is 5, times c, which is negative 4, all over 2 times a, which is 2 times 5, and then you just, once you've got it in, it's just being careful when you simplify. Alright, so the square root simplifies to 441 all over 10, which actually 441 is a perfect square. It's the perfect square of 21. Alright, so you get 19 plus or minus 21 over 10, so the two answers are negative 19 plus 21 over 10, and negative 19 minus 21 over 10, and so those simplify out to give me, excuse me, negative 4, or sorry, not negative 4, this is the 1/5 or 0.2, and then this is the negative 4. Alright, so two answers are negative 4 and 0.2, which is a fifth. Alright, those are the zeros of that function. And the solution to the original function. Alright, the last example. So again, same thing. I have to set it equal to 0 first, which means I need to move the 2 over. So 3x squared minus 6x minus 2 equals 0. So a is 3, b is negative 6, c is negative 2. Plug it into the quadratic equation. So opposite of b, which would be a negative negative 6, it comes out positive 6. Plus or minus, be careful here, it's negative 6 squared, so that needs to be, sometimes so that you don't mess that up, you can put in the positive version of it. Because remember, when I get negative 6 squared, it comes out positive 36. Minus 4 times a, which is 3, c, which is negative 2, all over 2 times a, which is 3, and then you just simplify. So 6 plus or minus, the root simplifies to 60 over 6. Don't cancel those 6's, they don't cancel yet. There will be a reduction. So the square root of 60 can be rewritten as the perfect square that you can pull out of that would be 4. 4 times 15 is 60. Alright, so 4 times 15, so I can pull the perfect square root of 4. The 6's, again, don't go anywhere yet. Plus or minus 2 square root of 15 over 6. And now we want exact answers. And so if you want to reduce that, you split the big fraction into two little fractions. So instead of everything over 6, you just divide it into the first term over 6 and the second. And then you can reduce. So my x term reduces into, well, 6 divided by 6 is 1. Plus or minus, the 2 divided by 6 reduces to 1/3 square root of 15. And then my answers are x equals 1 plus 1/3 square root of 15, or 1 minus 1/3 square root of 15. And that's exactly the answers to this problem. Right? Those are the exact ones. Again, we want exact things in math. Unless they ask you for the decimal approximate, give the exact answer. So that's exactly what the answer is. Alright, in the next section we're going to talk about the discriminant, this middle part here. That's what the discriminant is. Underneath the root, the b squared minus 4ac is called the discriminant. It actually will tell me if I get the 2 solution case, the 1 solution case, or the no solution case. And for the most part, so far, we've done the 2 solution case because that's the one that occurs the most often. We did one example with no solution. And so the next one, we're going to look at the outcomes. The 1 solution case, the 2 solution case, and the 3 solution case. And we can tell when we're going to get that based on what's underneath the square root in the quadratic formula. And that's what we're going to look at. And then we're going to talk about how you can solve these graphically in the next video as well.